In this unit, I will show you different ways to fuzz our target. The first one, it's the simple one that we already used in the other sections. We simply run AFL fuzz without memory limit, specify the input folder, in that case it's the RAM disk, the output folder, again into the RAM disk, the seed, and the tcpdump command that we want to fuzz, with all the flags. I would like to remark that we use the full output of tcpdump because more output can pass through more basic blocks. In addition, there might be some analysis logic that will not be enabled where more content is output. And we use the N flag or double N flag because we want to improve the speed of the fuzzing process by preventing tcpdump from performing time-consuming DNS and service name lookup. Okay, so this is the first way. We run it. It will take a while because we have many examples, many tests inside our input folder. And we just stop it. This is because we want to review the output of AFL file, as you can see, AFL complains that some test cases look useless, and it suggests to use a smaller set. Okay, so how can we create a smaller set? We have to trim our input. And to do that, there is another command that it's AFL cmin. What we can do is to run AFL cmin against our input folder, specifying as output another folder, always inside the RAM disk, and passing the command that we want to fuzz. In that way, AFL cmin will run all our inputs inside the in folder against our command, and will try to eliminate duplicates or inputs that they don't provide useful coverage or new exploration of paths. Okay, so as you can see from the output, we started with 521 files, and after cmin we have just 216 files that we can use as input for our fuzzing. So now we can run again the same command as before, but this time instead of the in folder as input, we use the corpse folder. That is the folder where that we specify in AFL cmin to put our trimmed input. Okay, as you can see, we still complain that we have too many input files, but now we are just using around 200 inputs. We can stop it again. Finally, another trick that we can use to speed up our fuzzing is to run many parallel fuzzing sessions. In particular, we need to first launch a primary instance that coordinates the fuzzing campaign, followed by multiple secondary instances. For best performance, it is suggested to limit the number of instances to match your available CPU cores. So for example, if you have 4 cores, you should use no more than 4 parallel instances. Most of the time you will see that using number of cores -1, it's the optimal for performance. Or at least adding the last one, the data increment of the last one is not as huge as the others. Okay, moreover, for each instance, we have to specify a unique identifier, and the primary instance manages synchronization while secondary instances contribute to the fuzzing process independently. To spawn many AFL++ instances inside Podman, it is suggested to use a terminal multiplexer, for example tmux or screen, and in this example we will use screen. Since screen is not already installed inside the container, we have to first install it. And now we can open a screen session simply typing the screen command. Press enter or space to close this page. Okay, now we are inside screen. So the first things to do is to spawn the primary instance. So we define a temporary directory for the primary instance with the export command, and we set in the AFL tempdir variable the directory for all the temporary files of the first instance, the primary instance, that I will call F00, Fuzz1001, just because it's the main. Then we have to ensure that this folder exists. So we also create this folder with the same ID. And then we can launch our Fuzzer like before, but this time we specify the capital M flag that stay for the master instance, the primary instance. And we have to specify a unique ID for the primary instance. In that case, I use F00 again, like the folder. As you can see, the input, it's our corpus. The output, it's the same as before, running this count, and all the other parameters are the same. Once the main instance is up and running, we can start spawn as many secondary instances as we want. To do that, we have to first open a new screen terminal, and to do that, we can use the key combination Control A to enable the command mode in screen, and then we have to press C to create a new terminal. And inside this new terminal, we do the same that we did before. So first, we define the AFL temp directory, but this time we use a different ID, a different name, for example, F01. We ensure that this directory exists. And we run our Fuzzer. The command is again the same as for the main instance, but this time we use capital S and we specified a different unique ID. The input folder is the same and the output folder is again the same. Okay, once you have spawned your two instances of AFL, you can switch between the terminal, pressing Ctrl A and N for next, or again Ctrl A and P for previous, or Ctrl A and quotes to show the available sessions. In that way you can switch between the sessions. To go back to the, let's say, normal terminal, to exit from screen without closing the running fuzzing, we can press Ctrl A and D. In that way we detach from screen and we go back to the normal terminal inside our container. From there we can start to monitor our fuzzing process. For example, we can run AFL.cpu. That will give you an idea of how many more instances you can run. In that case, I have 4 cores in my machine, so that means that I still can run. It is suggested to run 2 more instances of AFL. The next useful command that you can use, it's AFL what's up. You have to specify also the output folder of your fuzzing, but in that case it's ramdisk out. And this command will provide you a good overview of what's happening. So what we have is that we have 2 instances, F00 and F01, with all the data about the first one and the second one, in the nice recap at the end. In particular, here we can see the number of crashes, the total runtime, that is the sum of the runtime of the single sessions. So in that case, we let it run for 2 minutes. So we have a total runtime of 4 because we have 2 parallel AFL sessions. Then we have the cumulative speed. So the sum of all the speeds of each session, the average, and so on. We run it again just to see an update of results. And as you can see, we have a cumulative speed of, in that case, of 500 executions per second. Okay, but as we saw before, I still have space for more fuzzing. So how can I spawn a new sessions? What I have to do is first go back to screen. So I can use screen -R. Then I have to create a new screen terminal. So Ctrl A and C. And here I will do the same that I did before for the secondary session. I will specify a new folder as a temp dir with a new unique ID, this time 2, F02. I create a new folder and I run again the fuzzer, this time just with a different ID. And as you can see, in the dashboard, you will see the name of the session, of the instance. Okay, so let's go back again to the main terminal of the Podman container, Ctrl A and D to the touch. Let's check how many CPU I'm using. I'm using 3 CPU on a total of 4. So I have still one more free core, and I can check how the fuzzing is going with AFL WhatsApp. As you can see now, the cumulative speed is a bit lower than before, because when you spawn a new session, AFL needs sometimes to calculate the right values and the right statistic. So just wait a bit and run it again. It looks like we have to wait a bit more. And after some seconds, you will see that the cumulative speed increased and we have 3 fuzzers alive. And again, going back, you will see all the statistics for each individual fuzzer. Fuzzer 2, Fuzzer 1, and Fuzzer 0. Okay, now I will let it go for a while and see you to the next unit for the triage.